In problem number 17, we are asked to calculate the double integral of x minus 3y squared over the rectangle R, which is the rectangle consisting of points with the x coordinate between 0 and 2 and the y coordinate between 1 and 2. Let's begin by sketching this rectangle. Having a picture of the region of integration is helpful for setting up the iterated integrals that will calculate our double integral. And so x is ranging from 0 to 2, let's say 1 and 2 here, and then y is ranging from 1 to 2. Okay, so what we get is the following rectangle as our region of integration. Next, decide which variable you would like to integrate over first. In this particular case, it probably wouldn't matter much. So you could integrate over x first or over y first. In general, it may one order of integration may be more complicated than the other. So let's go ahead and integrate over y first. This means we're fixing the value of x. So imagine we choose certain value of x, of course, between 0 and 2. And we'll look at all points in our region of integration that have that x coordinate that we just selected. Now these points will lie on the vertical line segment that I'm drawing right here, where the bottom end of the cross section will have the y coordinate equal to 1, and the upper end of the cross section will have y coordinate equal to 2. And therefore our first integration will be from 1 to 2 over y. To 2 x minus 3y squared dy. And then once we're finished with that integration, the result, which will be a function of x, will be integrated over x from 0 to 2. And the reason we're integrating from 0 to 2 for the second integration is because for the points inside our region, the x coordinate takes values between 0 and 2. Okay, let's go ahead and calculate the first integral. So when we integrate a constant, and for the purposes of the first integration, which is an integration over y, I'm looking at this integral right here. This is an integration over y. The x variable is treated as a constant. So we choose a value for x for this integration, we keep it constant. So therefore, this first part, where we integrate the first part of the first integral, we're integrating x from the over the interval from 1 to 2 over y. We can use the following very useful formula, that if you're integrating a constant, let's say c, over whatever variable x or y, doesn't matter, the result is equal to that constant c times the length of the interval of integration. So c times b minus a. Of course, you can find the antiderivative of the constant, plug in the endpoints, take the difference, and that is exactly what you will see. But the reason I'm mentioning this here is because when we integrate x on the interval from 1 to 2, the length of the interval of integration is 1, and we're integrating over y, so x is treated as a constant. We get x times 1 as the value of that integral from 1 to 2 of x dy. Now for the second part, antiderivative, we need to use the antiderivative, and the antiderivative of 3y squared is y cubed. And here for the y cubed term, we will plug in our limits of integration, 1 and 2. And then the result will be integrated over x from 0 to 2. Okay, very good. Now, before we integrate over x, let's calculate what we get from y cubed if we substitute 2 and 1 for y and take the difference. 2 cubed is 8, 1 cubed is 1, 8 minus 1 is 7. So we get x minus 7 as our function that we need to integrate over x from x equals to 0 to x equals to 2. When you integrate x, the antiderivative is going to be x squared over 2. We will be plugging in the limits of integration 0 and 2 into that antiderivative. For the second term in this integral, when we integrate -7, -7 is a constant. And when you integrate a constant over an interval, the value of the integral equals to that constant multiplied by the length of the interval of integration. So the second integral, the integral of the second term, will be equal to -7 multiplied by 2. Almost finished here. And so now when I plug in x equals to 0 into x squared over 2, the result is 0. When we plug in 2, we get 2 squared divided by 2, which is just 2, and then 2 minus 14, which results in our answer being -12.